Intercepts can be used to quickly draw the graph of a linear equation. To graph a linear equation using intercepts, we will find and plot the x and y intercepts. Then we will draw the line through these 2 points and use a third point on the line as a check. Let's look at some examples. First, we'll draw the graph of the equation 2x plus 3y equals 6. Remember that one method we could use to graph this equation would be to solve the equation for y and then generate a table of ordered pairs. However, it's faster to draw the graph of this equation by finding the intercepts. First, let's find the x-intercept. Remember that to do that, we set y equals 0 in the equation. This means that the second term, 3y, would disappear. And we have 2x equals 6, or x equals 3. So the x-intercept of our line is the point 3, 0. Now we can find the y-intercept by replacing x with 0. This results in the first term, 2x, canceling out. So we have 3y equals 6, or y equals 2. So the y-intercept is the point 0, 2. We can plot these 2 points on the coordinate plane, 3, 0, and 0, 2. And then we can draw a line that passes through these 2 points. This line is the graph of the equation 2x plus 3y equals 6. But just to make sure we didn't make any mistakes in finding our intercepts, it's often valuable to use a third point on the line to check our work. We can see that this line does pass through the point negative 3, 4. So let's check that point in our equation to verify that it is a solution of the original equation. We replace x with negative 3, and we replace y with 4. And is the equation true? Well, negative 6 plus 12 does equal 6. So the point negative 3, 4 is a solution of the equation, which is what we expected since it lies on the line. Let's look at a second example. 5x minus 4y equals 20. First we find the x-intercept by letting y equal 0. So we find the x-intercept to be the point 4, 0. Next we find the y-intercept by letting x equal 0. So the y-intercept is 0, negative 5. Then we plot these 2 points on the coordinate plane and draw a line passing through them. For a check, we can find a third point that the line passes through. Let's use this one, the point 8, 5. Substituting into our equation, we have 5 times 8 minus 4 times 5. Does that equal 20? Well, 40 minus 20 does equal 20. The point 85 is the solution, and we know that we've graphed our line correctly. Let's look at one final example to see what happens when the x and y intercept turn out to be the same point. We're going to graph the equation y minus 2x equals 0. If we want to find the x-intercept, we let y equal 0. So we have negative 2x equals 0, which means that x itself is 0. So the x-intercept is the point 0, 0. Now if we were to go back and find the y-intercept, by letting x equal 0 in the equation, the negative 2x term would cancel out and we'd be left with y equals 0. So we see that both the x and y-intercept are that same point, 0, 0. This makes sense when we think about the coordinates 0, 0. That point is actually the origin, which is the only point that falls on both the x-axis and the y-axis. So it must be both the x and y-intercept of the line. The challenge with drawing the graph is we don't have enough information to know which direction this line goes. So what we'll do is return to our method of generating a table. We can solve the original equation for y by simply adding 2x to both sides. And then we can use that equation, y equals 2x, to quickly generate a table of ordered pairs. We already have the ordered pair 0, 0 shown. If we let x equal 1, we see from the equation that y equals 2. And if we let x equal 2, we see that y must be 4. So plotting the points 1, 2, and 2, 4 on the graph gives us enough information to graph the line as shown.